Good morning, sir. I am Lakshmikant. I am studying IRE, branch of Computer Science and Engineering, subject data structures. Today, my topic is optional resource catching in fog computing using stationary trees. Fog computing brings good like services closer to end user, enabling real-time data processing and reduced latency. A key challenge is optimizing the placement and management of cache resource occurs the distribute fog infaturation. This presentation will explore a synthetic tree based approach to take this problem. Introduction to fog computing and its challenges. Distribute infatuation. Fog computing extends the code to the edge with data processing and store closer to end user. Real time, expensive, low latency requirement for time sensitive applications. Return equipment, resource processing and management. Heterogeneous devices. Heterogeneous devices. Fog nodes can vary widely in compute power, storage, and network capability, posing presentation challenges. Motivation for optimal resource catching. Reduce latency. Catching resource closer to using the required to occurs data and SEOs. Bandwidth savings cache resource reduce the need to fetch data from distant code service, convincing network bandwidth, load balancing, augmenting changing can distribute the load across fog nodes, privating hotspot and improving overall performance. Overview of stationary tree problem containing terminals. The containing terminals. The stationary tree problem aims to find the minimum cost network. The contacts a set of terminals or nodes, terminal pairs. The solution manages the total length or weighting of the edges in the tree, finding the most efficient connections. Network designing. Stationary trees have applications in various dimensions such as telecommunication, VLSI design, and transformation networks. Computational complexity. The stationary tree problem is an NP hard observing problem, observation problem. requiring specialization algorithms for particle solutions. Formulation of optical chaining as a stationary tree problem. Fog nodes as terminals. Fog nodes that can cost caching resource are representing as terminal in the stationary tree problem. Edge weights. The weights of the degree edges represent the cost of data transfer between fog nodes capturing network constraints. Cost of data transfer between fog nodes capturing network nodes. Optical tree structure. The goal is to find the stationary tree that minimize the total cost of the caching infatuation. Stationary tree based caching algorithm. Graph graph constructions build a weighted graph representation of the fog computing network with fog nodes as terminals. Capturing placement. Stationary tree computation. Apply a stationary tree algorithm to find the minimum cost tree connecting the terminal fog nodes. Cache placements. Develop dipole, dipole, dipole caching resource that at the fog node selected by the stationary tree. Stationary tree computation. Apply of stationary tree algorithm to find the minimum cost tree connecting the terminal fog nodes. Placement of catching out nodes. Server capacity. Consider the available compute and storage resource at each fog node to determine catching applicabilities. Geography description. Place cache at staging location to minimize the distance to the need users and balance the load. Network connectivity. Forever nodes with store network links to necessary efficient data asset and transfer. Proportional cost. Consider the operational expense such as energy, computation, and maintenance when selecting catching nodes. Catch replacement and equation stranger. Last reconsider use LRU. Acute the list recently as a content to make space for new data. Last frequental used LFU. Remove the least frequental assumed times prevention popular connect size aware police policy. Consider the size of catched objects and prioritize a elimination of larger time. performance equalization and benchmarking. Matrix respiration importation latency time to ascend catcher cannot high throughput data transfer rate between fog nodes high catch head rate percentage of required surveyed from catch high energy compression power uses of the catching information medium. Conclusion and future directions. Optimizing catching the stationary tree based approach eligible effect placement and management of catch resource in fog computing aptitude stages dynamic catch replacement and equation policy can feature improve performance and resource utilization, improving traits, integrating machine learning and artificial intelligence can extend the tech intelligence of fog caching system. Thank you, sir.